Hello dear students, let us look at this theorem. If the angles subtended by the chords of a circle at the center are equal, then the chords are equal. So if I look at this theorem, it seems to be the converse of the theorem which we know that equal chords of a circle subtend equal angles at the center. So this is the converse of that theorem. Let us also prove this. If we analyze it, already it's being given that angles subtended by the chords at the center are equal. We have to prove that those chords are equal. Let us first make the figure. Let us have a circle drawn. So this is the circle and it will have a center over here somewhere. This is the center. Let us name it as O, and we have two chords which are subtending equal angles at the center. Right, so this is the chord and we have one more chord. So this chord and this chord, these two chords are subtending equal angles at the center. So let us subtend the angles at the center. Right, so this angle is subtended by this chord. Let us name it as AB. So this is chord AB and this chord is chord CD, and it also is subtending an angle at the center. Let us also join it to get that angle. So here we join this point D with O. We already have joined point C with O. So what we get another angle, this one, which is subtended by the chord CD at the center. And what is being given to us? That this angle AOB is equal to angle COD. This is given to us and we need to prove that AB is equal to CD. So let us write what is given in the statement as per the statement. So very first things first, given what is given? It's being given in the circle with center O, angle AOB is equal to angle COD. Right? This is already given to us. What do we need to prove? To prove, we need to prove that AB is equal to CD. That is, both the chords are equal to each other. That is what we need to prove. So what is going to be our proof? So if we talk about its proof, we will look at these two triangles again. I see that there are two triangles in this given circle, a triangle AOB and a triangle COD. They both contain the required chords. Let us use these two triangles. So in triangle AOB and triangle COD, what do we see over here? I see that OA is definitely equal to OC as they both are the radii. This OB is equal to OD as these two are also radii, and these two angles are equal already. So we can use one relation of side angle side to prove these two triangles to be congruent to each other. So let us do that quickly. OA is equal to OC. We will write for that radii of circle. Radii is the plural of radius, right? Now moving ahead, this is the side, then the angle AOB is equal to angle COD. This information is already given to us. And at last we have OB to be equal to OD. This is again radii of circle, right? So by side angle side, we can say that triangle AOB is congruent to triangle COD. We will write the reason by side angle side congruency criteria, right? So this is the reason behind it. Since now these two triangles are equal or congruent to each other, we know that when we get any two triangles to be congruent, all the corresponding parts of that triangle becomes equal to each other. So we are being given with the two sides of triangle to be equal to the other two sides and an angle to be equal to the other angle. So the only remaining side is this one, AB. It must be equal to the third remaining side of the other triangle, CD, right? So we will write it. This implies that AB is equal to CD. How do we know this? Because these are the corresponding parts of congruent triangles, and this only we wanted to prove. AB and CD are the chords and they now are equal to each other, so hence proved. We can write it like this. So what we can conclude with this, that whenever two chords of a circle subtend equal angles at the center, the chords are equal to each other. So I hope it is clear to all of you. Note it down for your reference. Thank you so much.